welcome to my channel. So last class we were discussing lesson electrochemistry. In that we have discussed about Nernst equation. So today we are going to do some numerical problems related to Nernst equation. So this question is there in your NCERT textbook, that is a solid example. So what is the question? Represent the cell in which the following reaction take place. Mg plus 2Ag plus gives Mg2 plus 2Ag, and the concentration of Ag plus and Mg2 plus as given, and we have to calculate the E cell if E0 cell is equal to 3.7 volt. So this question I will be discussing in detail because so many students are having the confusion which is the anode or where the reduction take place, where the oxidation. So this question we will discuss in detail. So first we have to represent the cell. So we know how to represent the cell. How to represent? First we have a right hand side and a left hand side, and a salt bridge will be there. The left hand side of the salt bridge we will be writing the oxidation, or we will say the oxidation half, and the right hand side will be the reduction half. So this is the way we used to represent. So this equation we have to determine where the oxidation take place and where the reduction take place. So first of all, already I have told this code 100 times. Anyway, oxidation, what is the meaning of oxidation? Oxidation is loss of electron, is it? So how I have given one code to remember what is oxidation and what is reduction. Oxidation with starting letter is O. O is having the same like our 0, is it? What happens if we lose our mark continuously? If we lose our mark, we will get 0. If we lose our mark, we will get 0. So losing of electron is oxidation. Related with that the code, that is loss of marks, what will it create? 0. 0 is same like our O. So oxidation means loss of electron. And what is reduction? Just opposite of oxidation. You will be thinking why I am telling in detail, because many are having the confusion how to represent by looking at the equation. So for that we are just giving in detail. Okay. Reduction means gain of electron. So from the equation I should know who is losing and who is gaining the electron. Mg is converted to Mg2 plus. A neutral Mg is converted into Mg2 plus ion. That means a neutral means Mg is having same number of proton and same number of electron. Now it is having plus 2 plus means it is having more positive charge. That means it has lost its electron. So losing of electron means it is oxidation. So Mg is undergoing oxidation. And it is converted to Mg2 plus. Mg2 plus means how many electron it has lost? It has lost plus 2 means it has lost 2 electron. So 2 electron it has lost. Now reduction. Reduction is the gain of electron. Gain of electron means some ion or someone has to gain an electron. We can look Ag plus. Ag is having 1 electron deficient. That is, it is having Ag plus. So Ag plus is converted into Ag means it has gained the electron. So Mg Ag plus 1 electron gives Ag. Okay. But here it is given that 2Ag has changed into 2. So we have to multiply this equation just with 2, because it is given in the equation 2Ag is giving 2Ag plus is giving 2. So we have to multiply here. Same we have to do here. So it will be 2 electron, it will be 2. So look at the 2 equation. We have seen that the electron number is balanced. So whenever we are writing oxidation half and reduction half for a cell, we have to balance the electron number. Okay. So now it is 2 electron. Now we know which is oxidation half. We know the reduction half. So it is easy to represent the cell. So first what we have to do? Oxidation. Oxidation means loss of electron. So Mg bar Mg2 plus. What is the nature of Mg? Mg is solid. It is given in the question. And what is the concentration of whatever it is there, whether the concentration is given, whether it is aqueous or whatever it is given, you have to represent it in the cell representation. Double bar. Who has undergone reduction? Ag. Ag plus bar Ag. Ag is solid. Ag plus the concentration is given as 1 mole. So this is the answer for the first part, represent the cell. So we have represented. Now what is the question? We have to determine the E cell. It is of different concentration. We know that Nernst has derived an equation to determine E cell for different concentrated solution. So what was the Nernst equation? E cell is equal to E0 cell minus RT by NF natural log. What we will write in the numerator? It is our oxidized state, and in the denominator we will write the reduced state. For the detailed explanation of this Nernst equation, I have already done a video. I will just give the link so you can watch it and you can clear all the doubts. I have a detailed explanation how the Nernst equation is derived and how this is oxidized status is in the numerator part and the denominator. So you can watch it. If it's not also, you can learn this equation just like E cell is equal to E0 cell minus RT by NF ln oxidized state by reduced state. So we should know what is R. R is 8.314. It is universal gas constant. Temperature is 298 Kelvin. N is number of electron. It depends upon the reaction. In some reaction it may be 1 electron transfer. In some it may be 2 electrons. So N is different for different solution. And F is Faraday constant. It is 96500 Coulomb. Okay, so this much value we have, and these three values are constant, and natural logarithm has to be converted into base 10 logarithm. How we will convert natural logarithm to base 10 logarithm? We all know that just to multiply the base 10 logarithm with 2.303, then we will get the natural logarithm. So natural logarithm can be converted to base 10 logarithm just by multiplying it with 2.303. So we can substitute all these here. So we will be getting a value like E0 cell minus 0.0591 by N. We just put R, T, then Farad and this 2.303. So we will be getting log oxidized. Who is the oxidized state here? We know that Mg has oxidized. So Mg2 plus divided by who's undergone reduction? Ag plus. Here only how? Here Mg2 plus is the coefficient is 1. Isn't it? Here it is 1. But in the case of Ag it is 2. So Ag is 2. So we have to put here 2. Otherwise if we do the calculation without putting 2, our calculation will be wrong. So already we know that if there is any stoichiometric coefficient, then the concentration term raised to that stoichiometric coefficient. E0 cell they have already given us 3.17 volt minus 0.059 volt. N, what is the number of N? We already know that Z gives Zn 2 plus 2 electron, and 2Ag plus 2 electron gives 2Ag. This was the equation of oxidation and reduction. So from this it is clear that it is 2 electron. That's why I told that whenever you are writing a half cell reaction or a reaction of this cell, we have to balance the number of electron. So it will be 2 and it will be log. From where we will get the concentration of Mg2 plus and Ag plus? Already it is given here. The concentration of Mg plus is 0.130 molar and that of Ag is 0.0001 molar. We have to write it square. Why? Because it is Ag square. And by doing, we are getting the value of 2.96 volt. Clear? So when you get a question like this, first what you have to do? First you write the anode and cathodic reaction, then it is easy. Then we can, if any electron number, any variation is there, we can balance it. Okay. Then what we can have to write? We have to represent this, then we can use the Nernst equation. It's clear? Okay, this is the second question which is there in the NCERT textbook. Very simple question. First we will discuss all the simple question. If we are able to do all these, then if some indirect questions are there, we can easily solve it. So the next question. Calculate the equilibrium constant of the reaction Cu plus 2Ag plus gives Cu2 plus 2Ag. By looking at the equation itself, you should understand Cu has changed into Cu2 plus. That means it has lost it, or it lost it 2 electrons. So that's the reason why it has changed into Cu2 plus. And Ag is converted into Ag. That means it has gained 1 electron. So what is the question? You have to determine the equilibrium constant. E0 cell is given. we know the equation relation between E0 cell and the equilibrium constant. What was the equation? Again, I am telling those who have not watched my video, you can watch. I have given a detailed explanation of all these. If it is not there also, no problem. Just look at your textbook. All the equations are given there. Take a book and write all the equations and learn it. Otherwise, you can't do any numerical problem. So, E0 cell is equal to RT by NF log ln Kc. What is Kc? That is equilibrium constant. Equilibrium constant. So, we have to determine this Kc. E0 cell is given. R we know. What is the value of R? 8.314. What is the value of T? 298 Kelvin. F is 96500 Coulomb. Okay. Now we have the value of E0 cell. What is it? It is 0.46 volt. It is 0.46 volt. So we don't know what is N. N value you have to get it from here. Is it? So how many electrons it will be transferred? Some may have the tendency, they can easily look at the equation, they know how. But some have a confusion how many electrons are transferred. So better you can write the equation like this. Then almost all the confusions will be solved. 2 gives Cu 2 plus 2 electron. From where I got this 2 electron? Because Cu has changed to Cu2 plus. If Cu has to change to Cu2 plus, it has to lose 2 electron. Here, reduction. Ag plus 1 electron gives Ag. Because here Ag is plus 1. Plus means it is having plus 1 charge. So it has to gain 1 electron to make it 1 Ag. But in the equation it is given that 2 Ag. So we can, or not only in the equation, we have to balance the number of electrons. So what we have to do? We have to multiply it with 2, multiply it with 2, multiply. So how many electrons are transferred in the equation? So before doing any numerical problem, please balance the electron number, because the number of electron lost and number of electron gained should be the same. So we can write 2 electron. So N is equal to 2. And if we substitute, a natural logarithm can be converted into base 10 logarithm just by multiplying the base 10 logarithm with 2.303. So we will get E0 cell, we know the value is 0.46 volt. If we put R, T, F and 2.303, the value will be 0.0591 by N. N is here 2 into log Kc. And here if we do all the calculations and the Kc value, we have to find out the anti-log of this and all. Or I can write that is 0.46 into 2 divided by 0.0591 will be log Kc, and by solving we get Kc is equal to 3.92 into 10 raised to 15. So we got the equilibrium constant value. Simple one. Clear? The next question, these all are the direct application of the formula, which are like the Nernst equation, the relation between the standard electrode potential and the equilibrium constant, and the third one Gibbs free energy and the electrode potential. These all we have discussed, and it is there in your textbook, all the 3 formulas. It's a direct application, okay? So the standard electrode potential of a diennial cell. So first one, they have given some data here, okay? What was that? The standard electrode potential of diennial cells. So what is the standard electrode potential means? E0. It is given as 1.1. Calculate the standard Gibbs energy for the reaction Zn plus Cu2 plus gives Zn2 plus Cu. So we know the relation between Gibbs energy and the standard free, and delta G is equal to minus NFE0. All these formulas are direct application, so it is easy. So minus NFE0. So we have to determine delta G. Minus N. So for that we have to determine how many electrons are transferred. So here Zn changes into 2 plus and Cu2 plus changes into Cu. So it is understood that is only 2 electrons are transferred. How we will know that? Those who don't know, just write the equation. Zn gives Zn2 plus 2 electron. Zn has changed into Zn2 plus means it has lost its 2 electrons. So this is the oxidation. Reduction. What is who has undergone reduction? Cu.
Cu2 plus, what it will do? It will gain 2 electron and it will convert it into Cu. 2 electrons. So N is equal to 2. Farad is 96500 and E0 they have already given us 1.1. And we have substituting all this value, we will be getting minus 2.1227 joule mole inverse.
So I think all these three problems which we discussed is clear for you. If you have any doubt, you can comment, and also we will discuss more problems on the next class. Okay, thank you.